There's a saying among developers, to err is human, but to really mess things up, you need a computer. That saying underlines the problem we have as developers. Our code is fragile, it breaks. How do we solve that problem? Hi, I'm David, and in this video we'll be exploring together how we can make sure that our code doesn't mess everything up. And along the way we'll see that the solution to this problem has added benefits, including one you probably hadn't thought of. But first, why do we have this problem? Why is our code fragile? Well, first, it's impossible to keep track of all the information that we need. The requirements, the user needs, the technology, they all evolve. The systems we deal with have complex interactions. It's impossible for your brain, for my brain, to hold all the rules and behaviors that are supposed to happen. All the specifications, all the use cases, everything the code is supposed to do. So how can we solve that? Well, before we go into that, the situation is in fact even worse than it seems at first glance, because as developers, some of the systems we work on deal with vital resources. We could be making sure that people get paid on time, or receive their Christmas gifts, or managing inventory that means life or death for patients in hospitals, or coding self-driving cars. Obviously and thankfully, not everything we do has that much importance, but some of it does. And even if all we are doing is making someone's life easier with a tool or more fun with a game, well, that's important too. People depend on our code. So how can we ensure that our code doesn't mess up everything at the wrong time? Well, let's be frank, it's not humanly possible. There's too much information to hold in our brains, it's too complex, it's beyond our capacity. But thankfully, I have good news. All this is within a computer's capacity. Here's what we can do: write additional code and have that code test our code. And that, ladies and gentlemen, is what automated testing is all about. It's about writing more code to automatically test that your code is doing precisely what it should. So what are the different types of tests? What are the added benefits? Well, before we go into that, how do tests work in practice? Simple really. We basically take our code, a function for example, and we say, when I send this input to the function, it should be returning this value. The basic canonical example is if I call the add function with 2 and 3, it should return 5. That basic concept can be extended up all the way to interactions with the interface. For example, on a website, if I click on a button on the website, then I check that I'm redirected to the next page. The simple atomic testing of functions that only have internal logic, that don't depend on the state of other parts of the code, or to use the technical term, pure functions, is called unit testing. Testing the whole system together, like my example with the login screen, is called end-to-end or UI testing. And there's an intermediate level that's integration testing or functional testing, where we're not interacting with the full user interface, but we're still making sure that the bits work together. This could typically be calling an API or a complex function that uses other part of the code or that interacts with a database. And my preferred way of testing is actually that intermediate way, integration testing. Why? Well, first, end-to-end testing tends to depend on how the user interface is implemented. And if there's one thing that stayed the same across the many years that I've been developing, both in games and apps and websites, it's that user interfaces change a lot. So end-to-end testing tends to be a pain. Conversely, unit testing means there's a lot of code to write for every single function. Integration testing hits that sweet middle spot. It allows us to test a lot more of the code base with fewer function calls. Oh, and incidentally, the proportion of the code base that's covered by automated tests is called coverage. Now, what are the 4 benefits of automatically testing your code? The most obvious advantage of setting up automatic testing of your code is that it provides better stability. Your code is less likely to break, or rather, when it does break, you'll know about it straight away. If you set up continuous integration and deployment, or CI/CD, you can add the tests to the deployment process to make sure that you only push clean code out to production. But stability is not the only advantage. You see, we often need to refactor our code to write the code in a way that is cleaner, or a way that takes new information or technology into account. When we do that, we want to make sure that the code has the same behavior before and after being refactored. And there's no better way to do that than to have automated testing set up. It's a kind of contract that says, this is what we expect as an output when we push in this input. Because when we're refactoring, we basically want better written code that does exactly the same thing as it did before. And making sure that the code behavior doesn't change is precisely what automated testing is for. But that's not the only advantage. You see, when we implement testing, It forces us to structure our code differently. Imagine you want to test a function that does loads of stuff like call an API and manipulate the data and saves it to a database, and that function is not working. I say imagine, but that's precisely what happened to me last week. I was adapting a code snippet I'd gotten from an AWS blog article, and part of it was not working. Writing tests allow me to quickly understand where the bug was coming from. But writing the tests and structuring my code so that it could be tested made me write better code, because I ended up better isolating the different bits of a long function into smaller, more manageable bits. Now, before I go into the fourth advantage, we need to talk about something else. You see, there are also costs. There are disadvantages of automated testing. Everything isn't perfect. For example, you can fall into the trap of writing too many tests for things that don't deserve it. I mean, in real life, testing the add function is just plain stupid. We know the plus operator works, and if it doesn't, well, we have other problems in life. Conversely, if your tests don't cover error cases, they can lure you into a false sense of security. You can end up thinking that things work because a test passes, but if you're not really testing all the cases, your code might only work partially. Finally, at times, it feels like writing tests is just as long and complicated as writing the code itself. But that additional cost is worth it when you see the fourth and final benefit. You see, as I mentioned in the introduction, people depend on your code working well, and that can be stressful. Automated testing gives you the peace of mind that your code is behaving as it should, that messages are being sent, that payments are getting delivered. That security, that peace of mind can be vital to our mental health as developers. It removes stress. At times, it might feel like automated tests add development time, but writing tests is actually faster in the long term, because well-written tests can work as a documentation and a safeguard. They're an investment against technical debt. They help discover and solve bugs much faster. Automated tests are an indispensable tool to have in your toolbox, both for the quality of your code and for your peace of mind.